here welcome to my YouTube channel. So today we're going to talk about uh, the Quicksort algorithm in my blog website. So today we're going to implement the solution for this problem. So we're going to go through it. Open statement given our sequence of n positive integers from a1 to am, where n is less than or equal to 10 over 5 and ai is less than or equal to 10 over 5 9, and the number k and k is less than or equal to 10. So the output is to print the kth smallest number in the sequence. So for the inputs, we're gonna have the first line, which contains two integers and k. On the second line contain n positive numbers, integers from a1 to a. On the output, we're gonna print the kth smallest number in the sequence. So for example, we have this input for the n is 6 and k is 4, and we have 6 number array contain this number. So after applying Quicksort algorithm, we're gonna bring out the output of -1, which is the fourth positive number in the array given. So now we will start coding in the solution of this problem. Okay, so let's start with the defining libraries to use. And I use the iOS film library is for input and output, and I use the vector library so that convert all the vectors inside of code. We have to use namespace from std. Doing this way, we can simplify defining std to our code. So we just don't need to write std like this every time. So first of all, we gotta make the main function. By some variables is in the input device for 64, because actually we don't need to specify, but more compatibility and by k 0, and C is to read the input from terminal. Vector is a one-dimension vector. Diagonal size 64, so we're gonna make a consistent here. We'll divide this into 64, so this one also 64, and we're gonna divide this vector with the width of n plus 1, because we're not use the zero phase indexing, so use from 1 to n. So this one should be our root of n plus 1. Use 1 phase intensity. We're gonna follow uh, the n to import the array elements. Gonna be 64 as compatible to other variables. Modify 9 is equal to from 1 to n in the notebook. See in the input function this so this tutorial I think we're gonna use a custom short function. This is kind of similar to the quicksort building function in C++. So we just gonna write it like this. We're gonna implement later. Okay, so after something, we're gonna see how we will bring the output into the terminal. We see how the A is the case highest number in the array. Make this one should be the less than sign. So as we notice, we see how we use less than sign less for saying we use double greater sign. Line. It's not line like this, it's only not the end. So we're gonna return 0 to make sure that this function is not gonna just reopen as expected. So as we said, modify a function similar to the Quicksort one short with a vector variable one dimension 62. This would be a pointer because as you know pointer is to so anything changed to this array is put into the sort function will be reflected inside the function and outside the function with the same array the same vector that we put in before. Yeah, so after that we're gonna have the A sorted vector. So we're just gonna bring the case greatest number in the array, in the vector. So we're gonna use pointer here. After that we identify integer L and integer R is for the array of our recursive call for this function. I'm not gonna dive into the understanding of the Quicksort because you can go to YouTube and Google and do research about it. So modify I is for L, J is equal to R. specify the middle of the picture. So as you know, the picture algorithm is just like doing with G. So after each node, G is divided by 2. So that should be really memory, no, it's not really performance effective because it's not memory effective, it's like memory effective. Because if you know, if we do the recursive call in a function, it's gonna cost more memory. So after this implementation, I think for the performance will be reduced to mm, n log n, because if we is uh, the auxiliary component, was that the performance of the Quicksort algorithm. So as for the memory, it will be increased. We're not gonna use a for loop right here. We use the do while loop to simplify the implementation. We're gonna make a do while, so do after here is while. So the condition is to break this while, to continue this while is I less than equal to or equal to j. Unit call swap function is the building function is to swap the values of two variables. I think you can implement this real quick, but it's too simple. We just need a temporary variable to swap between the two variables input inside this function. So we're just gonna split it. Just use that building function is very flexible and fast. So we're gonna put the AEI and H3 to this function to swap the value between them. Increase this I and decrease the J. I think you have doing good, you have done good, but this needs to be before condition do while. So we're gonna make a while. So we make sure that everything is which is greater than everything. Every AI is less than x, which is the middle of our recursive function. I mean the current one. If you think of the recursion in your mind, it's gonna be like the loop of the loop, like the children of the parents with the children of another parents. First, by the AI, whichever less than x. So after that, we're gonna skip till we found the AI greater than x. Applying the same idea. same idea and thinking to the AG is greater than I don't know X. So, but now we're gonna minus J. In this case, for plus plus I or I plus plus is just the same thing, but for some case for the most case we should use I plus plus. But in equation we should use plus plus I. Okay, this depends on each problem and situation. Constant. So after that, I'm gonna check the if I is less or equal to J, then we're gonna swap the 3. We missed the semicolon right here. In C++, it's a mandatory to leave a semicolon after every end of line. So end of line. So okay, I will skim the process of our resorting. I mean like strategy is stemming from the really high parents with the highest node, and the lowest one is called leaf. In each iteration or in each recursion, you're gonna find every x is less than every AI is less than x, and every HA is less than or is greater than x. So in that way, you can swap. Okay. I think this was a long time through. It was a long time that I didn't do algorithmic problem, so I think for a short time. Oh, okay. Yeah, it's very simple. It just like amplify too much. So like if we have another way of this one, like 8, 5, 7, 4, 9. So we're gonna start from that for the AI, we're gonna start from this. So please 8, press the X, press the 5 right here. That's the middle of the already. So we're gonna find everything AI with more than with greater than X. So right, this one 8. one is the J. I'm gonna go down to 4. I'm gonna go down to 4 is less or equal to x, which is opposite to this condition, so we just gonna move right this. So that's why we use a y here. So very simple, we just swap this volume. So you see it's already shorted afterward. That just equals that, so moving on to this condition. So after it's just a swap function as we already assigned a ratio. Okay, so it's just simple, but this just for one row, I mean like one height of the tree. So as we see right now, the tree of Quicksort is to be divided with each recursion. So now we're gonna break the tree down binary in binary. So we'll keep else is the tree. So this one is very simple. If arrows is less than 3, which means that we have something to sort in the arrows in the chain side of arrow to tree. So just broke the tree down in binary, but we're gonna have a condition. We need to have a condition to know if that branch is horizontal or not. So this one is a condition. So we're gonna make the recursion right here for the A. This one is the pointer is in this one. So everything changed in this one. I mean like all these A is the same thing, so because it's a pointer. So first one. I see the same thing. I'm gonna define the condition for the left, for the left, brain of the surrounding joint. The same thing. So yeah, so I think that's it. So after this implementation, I mean in the lowest recursion, it will have this y will make the lowest node coming out. So this y, because if I is greater than j, that means that I have only node with a single node in the level of the tree. So it's called the leaf. So after finding after reach to each leaf, we like the end leaf, because the tree is spread down in binary into end leaves, the lowest node. So after that, it will be inverse recursive have inverse vehicles to sort the tree. So the quicksort will be will be really well. Okay, so just test this out. Run. Okay, we have some errors. Okay, cannot clear name go for oh, didn't done. This one is convert can actually define a global variable as the main function. Here we can define it as a global variable. This one before that primary expression. What can this? Okay, okay. This is not to copy the AI comments. Okay, so because I don't think the compatibility like is a big problem for the online compiler. So I think that's it for this videos. Is terrible at the end, so just wanna finish here. I will develop myself to make like other videos on more complex problem. So just stay tuned. I'll upload more videos on this YouTube channel. Like I think the next one should be AFF, AFS, or DFS, and also some dynamic programming. Mm, that's more of the thing. So thank you for your watching my video. See you in the next one.